This conference will now be recorded.
Am I audible now? Yeah. Let us take the next example. Suppose here I'm taking int y is equal to 20. Then I'm calling a function fun and I'm sending as argument this y. Then this is my printf statement. I'm using this printf statement to print the y value. And y is a local variable in the main function. And here I am having a function called void fun. This is int x. And then I'm writing here x is equal to 30. This is my code. In this case, I want to know what will be the value of y after execution of what will be the value of y. 20, because here I am taking 20 and then I'm calling the fun function and I send 20. This 20 is received here. So currently x value is what? 20. Then x value got updated. This is local value updation. This is local int x got updated, right? Now when the control come back, it will printing this y, that is his own local copy, which is not having any changes. Because if I give you a copy and in that copy if you make any changes, will it reflect in my original copy? No, it will not reflect in my original copy. So that is why in this case, what will be the output? The output will become 20 only. Execute, compile and run. 20. Very simple one. Okay. Okay, let us take the next one. Suppose this time I'm bringing pointer into the concept. How? I'm sending ampersand y. So address of an integer I'm sending. So that means it is called as call by address. So that means when the function will be defined, when the function at that time, when the function will be defined. Am I audible, students? Yeah. When the function will be defined, it is not capable of holding the address of an integer variable. So what I need here to hold the address of integer variable y, definitely I need here a pointer variable int star ptr. So what this int star ptr is receiving is none other than what it is receiving is none other than the address of y. Then what I'm writing here, I'm writing here star ptr is equal to 30, right? And I'm printing that y value. The question here is what will be the value of y? what will be printed as the value of y? 30. Why it will be printed as 30? You know, it's very simple, sir. When this line will execute, int y is equal to 20, this line will execute. Sir, what will happen? One memory location for y will be created. In that memory location, the value of y will become 20. What is the address? 100. Now this is what you are sending to fun function. Then ptr is a variable. What variable? Pointer variable. Every variable have their own memory location. So for ptr variable, it is having this own memory location. Let it be 200. And what it is receiving is this ampersand y. So ampersand y is what? 100. Address of y. You know that inside the box we have value, outside the box we have address. So what it is receiving is the address of y. That means what? 100 it is receiving. It is receiving 100. Understanding my statement, guys? Next, what you are telling, star ptr is equal to 30. So what this star ptr means? Such star means what? Value at address. So now the statement becomes value at address. That's the meaning of star. That's the meaning of star. Star meaning is done. Value at address. And what we are left with? ptr. ptr means what? 100. So now what it becomes? Enter statement. Value at address 100 should be 30. That means wherever 100 is address, here 100 is address? No, because here 100 is kept inside a box. So here 100 is a value. Where 100 is address, here 100 is address. So it is telling value at address 100. That means where 100 is playing the role of address, go there and make the value to 30. That means what will happen? Sir, this 20 will be override by what? 30. Now when we'll print this y, what will happen? This is called 30. This concept is known as, guys, call by address. This concept is known as call by address. The changes that are taking effect in the called function, the function that gets called is called function. The changes that will take effect in the called function will automatically reflected back in the calling function. I don't need to send anything. I don't need to return anything to tell that changes have done. I will do the operation on my own. That reflection will automatically, that changes will automatically reflected in the caller function. This concept is known as call by address. So automatically in this example, what is the value of y, sir? The value of y will be 30. Execute, compile and run. 30. Easy. Feeling comfortable? Next. Let us take the next one. Just be ready with your pen and paper so that very easily you'll be able to do that. Here I'm taking a pointer variable in star ptr. Next, int x. Next, ptr is equal to ampersand x. Now this one you people have to give the answer. Okay. And for that you have to draw the diagram and everything. I will not give the clarity for this one. You have to make it correct. Printf x is equal to %d x. Next, printf star ptr is equal to %d star ptr. First tell me the output of these two lines. Okay, Madhulina, your answer is correct. What about others? Sir, it is very simple. Previous example only. Int x is normal, one is pointer variable. Ptr is equal to ampersand x. Ptr is holding address of x. Then star ptr is 0. Value at address ptr. Value at address ptr. That means ptr is having what thing now? Address of x. Then actually 0 means who will be 0? X will be 0. Now when I will print that, it is 0. Star ptr also 0. That means 0 0. Confirm once in the chat box, sir. Do I need to draw the diagram and give the clarity, or you will understand? Sir, both the answer will 0. Do you understand that, or I need to give the clarity by drawing the diagram? Easy. 0 0. Simple. Just you can give some space so that it will be printing with a little bit space. Next, I'm making a little bit modification here. What modification? I'm making one modification. What is that? Star ptr plus equal to 5. Yesterday only I talked about shorthand assignment operator, and here again I'm printing these two lines. What will be printed? What will be printed, sir? Good. 5 5. Same. Only thing is that shorthand assignment operator you are using. So star ptr plus equal to 5 means star ptr is equal to star ptr plus 5. Currently star ptr is what? 0. 0 plus 5 means what? 5. So star ptr will become what? 5. Star ptr and x are same, na sir? Always same. No, 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 no. If ptr is holding the address of x, then star ptr and x are same. since ptr is holding the address of x, that's why star ptr and x are same. So that's why this will be giving me 5 5. Compile and run. 5 5. Achha, printing in the same line, na? Let me go for a new line and print it there. Say for example, where? Yes, /n. That will be new line, and then this. Execute, compile and run. 0 0 5 5. Next, and after that, here I'm writing star ptr plus plus, and I have that same two printf statement. What will be this output, sir? Star ptr plus plus. Why error? It is star ptr plus plus. That is what they're asking. So what does it mean, sir? Star ptr value will be incremented by 1. No, 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 no. It's not 5 plus plus. If it is giving a value, then you cannot write here. But I'm writing star ptr. A hard code value cannot have that plus plus, or if it is an array name which returns a base address, that cannot be plus plus. If you write an array here, int a3, then you are writing a plus plus. This is not allowed. Why? Because, sir, here a plus plus means a is equal to a plus 1. This a is returning what? Address. Some address. There are also some address. Now on the left hand side of assignment operator, both are value, which is not acceptable because A returns address. A gives you the address. But here star PTR incremented means this line will force the X value to be incremented. It is not returning here as 6 or 5 or 4 like that, whatever. It is not returning anything to you. It doing some operation for you. It will go to the X location and increment that value. And X and star PTR are same. So star PTR incremented means what? Basically X value will be incremented. Star PTR incremented means X value will be incremented. So X will become what? 6. Star PTR will become what? 6. Now what will be the output? Execute, compile and run. If you have any issue in understanding, then only I will go for drawing the diagram, because so many days we are practicing by drawing the diagram for understanding this. Now I hope you people are comfortable enough for understanding this thing. Otherwise again I have to start freshly. We are almost ending of this topic of array, pointer and string. This is the last week. Next week we will start structure union, right? So this is the last stage. Now you should make it correct. Execute, compile. I need that output. Then next. What is the next one? Observe. Here I'm taking an array. Int arri is equal to 1, 2, 3. Next, int star ptri is equal to arri. Syntactically, compatibility point of view, it is okay. Why? Because sir, arri is the name of an array. Name of the array gives what? Base address of the first element. First element is what? Integer. So base address of the integer means what? What is the type of arri? Int star. What is the type of ptri? Int star. Compatibility point of view, 100% okay. Next, I'm having another array. This is character array. And here I'm writing 1, 2, 3. Sir, in the character array, can I write this type of thing? Instead of taking character, yes, we can take this type of thing. Why? Because even if you take any character, na sir, that character ASCII values are there. So here keeping 1, 2, 3 means basically those characters will be kept whose ASCII value is 1, 2, 3. Definitely some characters are there whose ASCII value is 1, 2, 3. So writing 1, 2, 3 basically indicates that. Suppose instead of 1, 2, 3, if I'm writing 65, 66, 67. So I'm storing 65, 66, 67, but indirectly what I'm storing, sir, capital A, capital B, capital C. Similarly, if I have 1, 2, 3 means some characters will be there whose ASCII value is 1, 2, 3. Understanding my statement, guys? Char star ptrc is equal to arrc. This is also same with the same clarity. Sir, compatibility is okay. Now here I am having print statement size of arri is equal to %d, and here I'm writing size of arri. Then it is another printf statement. This time here it is size of not arri, size of ptri, and this is ptri. Similarly to that, let me copy this size of ARRC, PTRC, ARRC, PTRC. Think a bit and then give the answer. What will be the output, sir? Acha, first of all, size of ARRI. ARRI is what type of array? Integer type of array. Normally, modern day compiler integer size is 4 byte. So if 3 element is there, then automatically this size will be 3 into 4, 12. So this will be 12, sir. Next and after that, pointer. Sir, already we mentioned one point that wherever size of integer is 2 byte, their pointer size is 4 byte. And wherever size of integer is 4 byte, their pointer size is 8 byte. So modern day compiler, everything everywhere use size of integer is 4 byte. Then size of pointer 8 byte. Does not matter whether it is the integer pointer, character pointer, float pointer, double pointer, any type of pointer. It gives you address means some integer value. And address is basically means what? Unsigned. That means it is what? Long. That's why pointer size is always 8 bytes, sir. Wherever integer is 4 bytes. So automatically, first two answer will be respectively 12 and 8. Similarly, this is character array size, where each character is 1 byte. So it will be 3. And again, size of pointer, which will be 8, though it is a character pointer. So 12, 8, 3, 8. Execute slash n slash n slash n. Execute, compile and run. 12, 8, 3. As per our expectation, it happened. Sir, that means is it compiler dependence? Compiler dependence is there. Is it compiler dependent? Definitely it is compiler dependent. In this current compiler only it is giving you this, doesn't mean that in every compiler it will give. So 100% it is compiler dependent. If we check this code in Turbo C, definitely we will get a different set of output there. Next. Let us take the next one, sir. For example, here I'm taking a float array. Float ARR 5 is equal to, I have some value here, or just ARR. Some value is there: 12.5, 10.0, 13.5, 90.5, 0.5. Next, float star PTR1 is equal to ampersand ARR 0. Is it compatibility matching, sir? Yes. Why? Sir, ARR 0 is having a floating point number. And you are giving me what? Address of a floating point number. That means what about its star? What about its type? Float star. I'm capturing where? In PTR1. What is its type? Float star. Compatibility point of view, 100% okay. Now I'm writing here float star ptr2 is equal to ptr1 plus 3, and then I'm printing percentile f here. I'm writing star ptr2, and then I'm writing printf percentile d. I'm writing ptr2 minus ptr1. What will be the output in this case? Tell me, guys, what will be the output in this case? Okay, sir. If I keep it in the array, suppose I'm keeping it in this array. Okay, let's see. I don't know. I'm keeping this in the array. First, second, third, fourth, fifth. Let us assume the addresses are 80. First one. Float take 4 bytes. Next address will be 84, sir. Next 88, 92, and next 96. Okay. Float star ptr1 means ptr1 is a variable. Every variable must have its own address. Let it be 100. Now what it is having? Or say 400. Anything? 400. What it is having? Address of ARR0. ARR0 is what? 12.5. Its address is what? 80. It is having 80. Next, star ptr2. Float star ptr2. Sir, ptr2 is another variable. Normal or special? Special. It is having its own address. Yes, having its own address. Let it be 200. And what it is having is ptr1 plus 3. ptr1 is what? 80. Normal value? No. Address value means special value. Plus 3. Oh, 80 plus 1, 80 plus 2, 80 plus 3. That means what, sir? 92. That means what, sir? 92. So this is done. This line is also done. Sir, star ptr2. From your childhood you are doing, guys. Sir, star means value at address. ptr2 means 92. So value at address 92. What is that? 90.5. Floating point number we are printing means after decimal point it will consider 6 digit. It will consider 6 digit. That's a convention. So 90.5 is not exactly correct answer. It will be having in total 6 digit. 3, 4, 5, 6. This is what is going to come, not a 90.5. Understanding? Because if one option is there 90.5 and if you tick that option, it will become incorrect. And another option is 90.5 followed by 5 zeros in total after decimal point 6 zeros. That is more appropriate. Now ptr2 minus ptr1. What is ptr2, guys? 92. Minus ptr1. That is 80. So 92 minus 80. What is the answer? 92 minus 80. What is the answer? Oi. 3. Then why you said 12? It is 3, sir. Why? Sir, 80 plus 1. 80 plus 1. 84. Sir, 80 plus 2. 88. 80 plus 3. 92. So if 80 plus 3 is 92, guys, mathematics, that means what? Sir, 92 minus 80 will become what? This is mathematics. 3 now. Sir, why this kind of stuffs are happening? Because this 80, this 92, these are not normal values. These are pointer variables. These are special values. That is why this type of behavior. Understanding? So what is the output, sir? 90.5 followed by 5 zeros. And then we have 3 as the answer. Execute, compile and run. 3 is not that much clearly visible. Let's do one thing. Give a space. Execute, compile and run. Perfect. Happy. Now you people should do this because so many examples we practiced. Terminology is very clear. No chance of mistake anymore, sir. So let me erase this one. What is this answer? .5 1 2 3 4 5. I don't think this 5 is having any relation with this 5, guys. Don't think here 5 that means 5 zeros. No, here can be anything. Here can be 7 also. Only thing is that after decimal point you will have 6 digit in total. No one have any relation with anyone here. Next, and after that, sir, let us take the next one. I'm taking one array here, integer array, and having some element 10 20 30 40 50 60. Done. Int star ptr1 is equal to arr. Compatibility? Okay, sir, no problem. Int star ptr2 is equal to arr plus 5. Okay. Printf number of element between two pointers are percentile d, comma, what are two pointers? ptr2 minus ptr1. Next, printf number of bytes between two pointers are percentile d. What is that? ptr2 minus ptr1. No, I'm making it typecasted to char star. I'm making it typecast to char star. Done. What will be the output, sir? Think and then give the answer. What is the answer? Okay, sir. Observe here. Array, no problem. Two pointer variable, still no problem. One is this, another is this. Next, this is one fellow, ptr2 minus ptr1, and this is another fellow. Observe here. First activity is what? Sir, draw the array. How many? 6. 1, 2, 3, 4, 5, 6. 6 elements are there. Let me enter the values. 10, 20, 40, 50, 60. Address I need, suppose, okay, 200, 204, 208, 212, 216, 220. Okay, sir. Name of the array is ARR. Then PTR1. PTR1 is having what, sir? ARR. ARR means name of the array. Say this address is 400. Then PTR1 will get what? Base address. That means it will get 200. Yes, 200. PTR1 will get 200. Done. Then PTR2. PTR2. This is my PTR2. Assume that it is having own address 800. Then what it is getting? ARR plus 5. So ARR is 200. Then ARR plus 5 is what, students? Plus 1, plus 2, plus 3, plus 4, plus 5. 220. 220. Means what? Sir, 200 plus 5 is equal to 220. That means what? 220 minus 200 is equal to what? 5. Now you see first one. PTR2 minus PTR1. What is PTR2? 220. What is PTR1? 200. So 220 minus 200, what will be the answer for first one? 5. No doubt about that. Next, number of bytes between two pointers are. First, forget about this typecasting. Forget about the typecasting. So number of bytes between PTR2 and PTR1. You tell me number of bytes between 200 and 204. How many bytes is there between 200 and 204? How many? 4. Then how many bytes is there between 200 and 208? 8, 12, 16, 20. So number of byte between 200 PTR2 is what? PTR2 is what? 220. PTR1 is what? 200. That means number of bytes between them is 20. Let us verify up to this, then we will bring typecasting into the picture. Execute, compile and run. So number of 1 minute. Both become same, na? Number of bytes, both I write same here. So that's why both are coming 5. That should come as 5. That's why it is coming. So number of bytes is actually 20. So how can I get that 20, sir? PTR2 minus PTR1 is what? 5. 5 into 4, 20. Okay. By that I cannot be able to show you that 20. But if you see the diagram, number of bytes between PTR2 and PTR1 is what? Definitely 20. No doubt about that. Definitely 20. But it is not showing as 20, sir. It is showing as 5. Why? Or it is showing as 5 as because you write PTR2 minus PTR1. Na? You write PTR2 minus PTR1. So that means what? 220 minus 200. 220 minus 200 wherever you write. Do you think it depends on this message? No, it doesn't depend on this message. Whatever it will be calculated, that will be printed. In both the cases it is 5. That's why it is 5. No. I don't want to see 20. I don't want to see 5. I want to see that difference. I want to see that difference, sir. In between that 20 byte is there. So 20 byte you want to see, na? That means what? 200, 201, 202, 203. Like that, once it reaches to 220 means 20 byte. So that is what you want to see. Yes. So what I will do here is that currently why you are unable to see 220, currently why you are unable to see 20? That as because PTR2 and PTR1 is what type of pointer? Integer type of int star. What type of pointer? If I ask what is the type of PTR1, you will say what? Sir, int star. What is the type of PTR2? Int star. Then when they incremented, I told you now how they incremented. Remove the star. Whatever will be left, by that size it increment. So they increment by what? 4 bytes. That's why 200 plus 1 is 204. Plus 2 8, plus 3 12, plus 4 16, plus 5 20. So if you now decrement also, same thing will happen. 220 minus 205. Why 5? Because size of the integer is 4. No, I want to see that 20. That means you are thinking about size as 1, na? Not as 5. You are thinking about to see size as 1. Then you ask PTR2, why PTR2? I know that you are an int star pointer to an integer. Please don't behave like integer pointer. Can you behave like a character pointer? Character pointer means how it will be incremented, guys. Sir, leaving star, whatever will be left by that size. That means by 1. Similarly, ask PTR1. I know that you are integer pointer. but just in this line behave like a char pointer. After this line again you will behave like integer pointer. Typecasting means just in that line behave like that. I'm asking PTR2 and PTR1, oi, don't show your original talent. I am very much aware of your original talent, that you are int star, but behave like a char star. So if it is behave like a char star, guys, then 200 plus 1 should be what? For integer pointer 200 plus 1 is 204. Then for character pointer 200 plus 1 will be what? 201. 200 plus 2, 202. 200 plus 3, 203. Then 200 plus 20, 220. Then 220 minus 220 minus 200. Then 220 minus 200, it will be 20. Now you will get that 20. Observe here. Execute, compile and run. See? Number of elements between the two pointers are 5. Number of bytes between the two pointers are 20. That's as because of I typecasted. Sir, if I go to the next line and again I subtract PTR2 and PTR minus 1, sir, it will give me 5 now. Yes. You write the same message here. Now again it will become 5. Because character pointer, because typecasting doesn't mean throughout the program it will be changed. Only in that line it will be changed. You see, number of bytes between this 20, then again number of bytes between the two pointer is 5. Because in this line again they have started showing their original talent. What is their original talent? Int star. Just in this line I asked, hide your original talent. Whatever I am asking, do it accordingly. I ask you to behave like a char star, so behave like a char star. Clear na? Yes, sir. Control Z, Control C. Okay, sir. Tomorrow we will have our session, right? Tomorrow the very first example that I will show is a very interesting one, guys. Today, whatever time left, by that it will not be completed because a bit lengthy discussion is left, right? But that's a very interesting example. So many new things we will learn from the next example that I am going to show you tomorrow, right? Yeah. Thank you, students.